In this video, we're going to take a quick look at factoring using Algebra Tiles. Now, you'll notice I am on a website. This is mathspot.com. We're using the tiles manipulatives. You also might notice that factoring and factorizing, that looks a little bit weird. That's because it's not American English. So we can roll with that. So here's how it works. We start with algebra tiles first by recognizing what they represent. So they use area to help us represent polynomials. So this blue tile here has an area of x squared, meaning it's got a width of x and a height of x. So if I am asked for 2x squared, I would grab two of those big blue squares and bring them over, and those are my 2x squareds. Now the green rectangles have an area of x. They have a height of x, meaning they match up with the blue, but they have a width of 1, and 1 times x would just give you x. So we're going to go ahead and pull in 3 x's, and then each of the yellow squares has an area of a 1, meaning it is 1 times 1. And typically when you start with algebra tiles, you would start with just modeling the quadratic like this. Now, if you are asked to factor, this plays off of like what's called the area model, and it's a very visual way to picture what you're doing. Now, the rule for this is you've got to make a rectangle. Okay, you got to arrange these tiles so that they make a rectangle, and the length and width of that rectangle would be your factors. The rule for arranging them is that every side has to match up with a side of the same length. So you can buddy these up, but you can't do, say, this. Okay, because you cannot put a short edge on a long edge. You can put that next to, well, I guess I would need to rotate, like this would be okay. All right, well, I should move it down. Yeah, okay. So that arrangement would be okay, but you couldn't put, say, the one right there. All right, so what I would have my students do in class is, now that you know the rules, go ahead and try to make a rectangle. So we might do this, and then we might arrange this. We'll put one down here. And you figure out pretty quickly that you need to have x's on both sides there. So like if you try to put all of them on one side, you won't be able to make a rectangle. And look at this. So the one fits in there. And then you would simply look at the length and the width of that rectangle, and that would give you your factors. So this would be x plus 1, because we have a distance of x and a distance of 1, so x plus 1. And this would be x and then another x, so 2x plus 1. And so the factors are x plus 1 and 2x plus 1, and you could put those in either order. Oh, look, 2x plus 1 and x plus 1. Let's take a look at another example. Okay, well, let's do this one. So we have 2x, and now we need 4 x's. So we'll go and pull those over, and this time we need 2. All right, and then the puzzle commences. How do you arrange those to make a rectangle? Well, these guys have to go side by side, and then we need to split these ones up. So I'm gonna go ahead and rotate. I know I need at least 2 of them rotated so that I can put them down here. And oh, look. I think we got it. Now, sometimes it does not come together this nicely. So this one factors into 2x plus 2, and then x plus 1. And now it's a common factor in there. So you could factor out the 2 there, okay, and get 2 times x plus 1 times x plus 1, meaning that you would have 2 of the same thing there. All right, let's take a look at another one. I'd like to see one with a negative. Let's do this one, though. I wanted to look at this one before. So because this one has the 3x squared. So let's go and move that. So we're going to need another one of the x squareds. And we're going to need a couple more of the x's. and one more of the ones. All right, so the reason I want to take a look at this one is the first time I had my students do this, I had them try to do this. Like I had a lot of students try to do this and then try to fill it in. And the reason you can't do that is that rule that every side has to match up. And so if you look at the placement there, this side is okay, like the top side, but not the left side. And so that actually violates our rules. So whatever we're going to do with these boxes here, they have to all be in a row. Now, if you had 4 of them, then you would have some options. So if I pulled over the 4, then you could do that. You could either put all 4 of them in a row, or you could chunk them like that. That would work as well, but you would have to have 4 of them. If you've got 3 of them, you can't do that little L thing. All right, so let's take a look and see what we can do here. So I'm going to start by filling this in. I know I'm going to have some on either side. Like I said, you can play around with that if you have time to like play with algebra tiles. You would be able to figure that out. All right, and these ones look like they might fit right here, and then these ones will fit in like that's beautiful. And so we have 3x plus 3 growing across the top. Okay, again, a common factor there, and x plus 1 going down. So 3x plus 3 and an x plus 1. Now, I'd like to find one with a negative. Oh, I need to tidy that up. Okay, so we'll do this one. So 2x plus 4x. So 1, 2, 3, and 4. And then for the minus 6, we're actually going to use these negatives because we want them to be a negative 6. And we're going to have to be very careful with doing this. And this will be the last example that we'll do because we don't want the video to get too long. All right, so here we go. Now, using our rules, okay, we know these two are going to have to buddy up. And we're going to have to split these ones up. And I want you to notice what's going to happen. So that, and we'll rotate that one. And there's 2 things that are not going to work with this. One is that I clearly cannot make a rectangle with it because I have all these extra ones over here. The other is an issue with the sign. This is a positive 1. Okay, it's got a side length of 1, and 1 times 1 cannot give me a negative 1. So you're looking at that area. The only way to get a negative 1 down there would be to have positive x's on one side and negative x's on the other. So that leads us to, well, okay, what do we do? Because this doesn't make a rectangle. If you were to bring in a positive x and a negative x, okay, and you bring them in together, positive x plus negative x is 0. And so this is what's called a 0 pair, and you're just bringing in that 0 pair. So what that's going to allow me to do is put some of these other ones where I actually don't know which way this is going to work. Let's do this. I'm going to put these ones down here. And what you can't do is mix positive and negative x's on the same side. Okay, that's not going to work. So I'm going to bring all of these down. Okay, and then I have to rotate this one. We're going to put this one on the vertical side. So now I've got positive x's on one side and negative x's on another side, but I do have this problem where I still don't have a rectangle. So I'm going to bring in another 0 pair, and you can do that as many times as you want. So as long as I'm bringing in 0, we're good. And let's rotate that. And now let's see if we can get these ones to fit. Positive times a negative. So let's take a look. Oh, looky here. And it does work. So going across the top, this is 2x minus 2. Okay, because it is negative on each side. So 2x minus 2 and x plus 3. 2x minus 2, and x plus 3. And then there is a common factor there. Now, if I were doing this in my class, I would have my students factor out that common factor at the beginning because it would simplify some things, but you can also factor it out at the end. And that is your like 10-ish minute lesson on how to use algebra tiles to do factoring problems.